So I've realised that my title is slightly misguided, because my ideas for monitoring seagrass, colonising seagrasses, haven't really changed. But probably the way we use and inform our synthesis of this information is what's been evolving. So, first of all, I want to point out that I come from an area in Australia where the temperate, large Posidonias, amphibolyses are the dominant seagrasses and are what people think of when you say you work on seagrasses. So it's a little unusual that for most of my career I've focused on the colonising seagrasses in estuaries. We've got large monospecific seagrass beds of Halophila ovalis in many of our southwest estuaries, and other species that are prevalent in those systems are Zostramurei and Ruppia megacarpa. So I'm going to touch on three of our estuarine systems where we've been doing work for probably the last 7 or 8 years. So the Swan-Canning is the estuary in Perth, Perth being the capital city, so the most urbanised area in Western Australia. The Leschenault, a few hundred kilometres south of Perth, north of Bunbury, is a lagoonal system, and the Wilson Inlet's on the south coast. So the dominant seagrasses in the first two systems are Halophila ovalis, but once we get down onto the south coast, Ruppia becomes the dominant species down there. So I just wanted to show you a little bit of an overview of these two systems. We had some drone footage recently, so this is a Leschenault Estuary from the air. As you can see, large bands of seagrasses in the coastal pattern there. This system is connected to the ocean only at one end down at the cut. So there's a salinity gradient, and the top end in summer gets particularly hypersaline. Underwater, oops, sorry, anyway. I've got sound, had no idea. Underwater you can see there's a large amount of macroalgae sometimes present, fine pieces of Ruppia and Halophila ovalis underneath there as well. So 11 years ago when we started this, sorry, not 11 years ago, in 2011, when we started this program, I was inspired by a recently published paper by Hilary Nichols which promoted a hierarchical approach to monitoring. And really everything I've done in these systems since then has been inspired by this approach. So at a very broad scale, we do some sort of mapping that's essentially designed to tell you what's where. We tend not to use this information for change because the errors associated with it are too great. Then we step down to a meadow scale monitoring, which we do on an annual basis. This is far more high resolution and can really tell us how things are changing, whether it's the species cover, the presence, absence of the seagrass or the species that are actually there. And then at a finer scale, which is where I spend most of my effort and thought, we take quite intensive data using cores, processing things for meadow characteristics such as growth, density, flowering, reproduction, and really have this very dense amount of information that underpins that broad-scale observation. So you can see on the right-hand side I've got a schematic of spatial extent being very broad but the temporal frequency being very tight, down to the temporal frequency being far more informative but actually only at a few number of sites. And we try and nest those things together to help us understand the system and also how to manage it. So we have this large amount of information, and I work in a management organisation, so we're constantly trying to think of the best ways to put this information together to a combined metric in which to really help us inform management. So the management in our catchments is catchment management. We're primarily looking at water quality improvement and hopefully hoping to use the seagrass as an indicator of estuary health and water quality as an integrated measure. So these seagrasses are highly responsive to the environmental conditions of every year. So we realised quite early that we wanted to be able to develop an indicator that talked about seagrass performance as an annual scale. But what we see, so we've done this preliminarily with meadow scale information about presence and absence and the changes from year to year. The seagrass cover is a percentage cover. Productivity, so growth measurements, and also the reproductive characteristics and success in those samples. And we've got a combined measure that changes from year to year with this information, primarily as a response to the environmental drivers. But as a manager, you actually really want to know more about the anthropogenic stresses on those systems and whether you can understand what is causing the change, if there's a change that you can do something about. So that interannual variation that's caused by climate, we probably can't do much about it as a manager, but hopefully we might be able to do something about localised nutrient inputs that are driving things, etc. So we've got a whole nother suite of measures that are looking to provide sort of functional level indicators of the key pressures at each site. But increasingly we've been actually considering not looking at either of those elements and looking at whether the seagrasses are resilient. So will they be there? You know, how much, how can you support, as a manager, how can you support the aspects that will enhance resilience? So we had that huge suite of information, packaging it a different way, or thinking about packaging it a different way. This is pretty much where my work is at the moment, thinking between those different indicator types and trying to work out what the best way to look at our last 6 to 7 years of information for the Swan-Canning and 4 years for the Leschenault. Most of that initial work was based around the Halophila ovalis being the dominant species in those two systems. And we're now more recently looking at how we can adapt that sort of thinking to talking about Ruppia and other systems. So I'm going to touch on 3 aspects, one from each of those 3 systems. Firstly, looking at the patterns and drivers of sexual reproduction in Halophila ovalis that we've seen. In the Leschenault, we have a story of loss and signs of recovery. And down in the Wilson Inlet, just touching on how that sort of hierarchical principles can also be used to inform. So in the Swan-Canning, our first year of study spanned a much larger time period, but we really picked out this targeted summer sampling period as being the time when flowering and reproduction was greatest for seagrass. It's also high productivity, and this is what every subsequent year has pretty much focused on this period. If we now look at the, this is 5 years of data. Between 2011-12, there's a missing year while we worked out what we were doing, and then continuous from 2013 through to 2016-17. And you can see there's actually quite a variability both in the flowering and the fruiting. This is pulled from all of our sites. But we've got 2 years where flowering and fruiting just was so much more successful than other years. When we look at the environmental drivers, you can see that these were years of really high light. Interestingly enough, the year immediately preceding it, if you only looked at the environmental drivers, you would have thought that it should have done really, really well. But we had some late spring rain, increase in macroalgal bloom, and the macroalgae absolutely competed in that year. So this is something I found quite interesting. So really looking at the sexual reproduction from a resource potential. So generally most of our flowers are males. Halophila ovalis is dioecious, so there's either the male plant or the female plant. And this is taking the number of cores where we saw male or female plants. You don't know whether you've got a plant that's male or female unless it's flowering. So until Michelle helps. But what we see is that there are years of good sexual reproduction are also the ones where greater investment in female flowers has occurred. And females are known to be more costly from an ecological resource perspective, so that's quite interesting to see. We also see site variation in this across the years as well. And now this is looking from a site by site, so I've got more data points here because I've got multiple sites, multiple years. and looking at that effect of the nuisance macroalgae that's delivered from spring rainfall catchment interaction nutrient delivery. And the more macroalgae there is in that period immediately preceding with flowering and fruiting effort, the less flowering effort goes in. So moving on to our recent loss of seagrasses in the Leschenault Estuary. So between 2009 and 2015, we lost probably about 30% of the seagrass area in the Leschenault Estuary. This was a period that we didn't monitor between those times, so it's not exactly sure what event knocked it over the edge. To be honest, it was probably a combination of things. And given the greatest loss appears to be on the northern end, my suspicion is that hypersalinity had a pretty big impact. So we've monitored the system each year since, and we've seen that there's been an aerial sort of stability up until this last year, where we have actually seen seagrasses start to recover at the aerial extent. So if we look at our sort of spatial hierarchy now, at the largest spatial extent, we can see that seagrass cover has increased in this last year. We get a similar sense of information, except that we can be statistically sure about it at the meadow scale. So between year 3 and year 4, we saw a great jump in the seagrass cover. And this information that you're seeing in the second plot is actually a depth transect, or a summary of several depth transects at one of our sites, just with the percent cover shown. But very interestingly, we had signs that things were getting better 2 years ago. So because of that process scale information we were collecting, we saw that the fruit densities that we were measuring in our meadows 2 years ago showed evidence of recovery processes. And certainly this last year, what we're actually seeing is expansion of many small patches, and I'm pretty sure that that's due to the flowering. So finally, down in the Wilson Inlet, we've taken a slightly different approach, done a broadscale mapping based on a randomised design, but we also noted this area down here near the town site. I can't get that to... So across in the top, across over here, near the town site with the largest potential impact, this is where we see the lowest density of seagrass. And previous information also showed a lack of density down there. So I was interested to know if that was a sort of bottleneck, recruitment bottleneck, whether we didn't have flowering. So when we went out in December that last year, the orange dots are areas that we noted that there was prolific flowering. So we went back down in April and took some seed cores, and from 4 areas where we'd seen seeds, 4 areas where we saw prolific flowering, 4 areas where we didn't. And we see there's about half the density of seeds in that area with low recruitment. But we still don't quite know whether that's how much seed production's enough. 200 seeds per square metre, that seems like quite a lot. So that's one of the questions we need to understand if we need to know that for management. So finally, just looking at linking seagrass response to environmental conditions really helps aid interpretation of these colonising species. Our hierarchical monitoring, I think, has been a real win for us. Really helps us understand and track those recovery processes as a manager, gives you that confidence. And we're still very much working on the best indicator combination to use. So, thank you.
Thanks very much, Kieryn. How much longer do we have, Marcus, for questions? 2 minutes, okay. We've got a bit of time for questions, if anyone has some. Sitting all the way at the back if you move forward.
You said that in the first estuary there was a relation with the hypersalinity. When you registered the recovery of the seagrasses, does the salinity also tend to lower, or it was the same?
So there is a salinity gradient in that system. I think there was a year where we had extremely low rainfall that year, and I believe that the salinity probably in that top end got above 50 parts per thousand. So now it's more like 40 parts per thousand in summer. But there's also, I think there's a connectivity issue as well. That top end is still absent of seagrass to a fair degree. I think generally conditions are probably supportive of it, but managing that water cycle becomes important. Yeah.
Okay, we've got time for one very short question, if anyone has a quick one.
It's not really a question, it's more, I think it's very impressive data that you can say a lot about ecosystem services based on this data, and it's based on area, and it's even distributed measuring points compared to, in Denmark we only have the depth distribution in transects that are where they are looking at the same meadows every year, and here you are covering more or less the whole shallow part of the system. I think it's very excellent. There's a lot of potential in this data. I would love to have similar data available in Denmark that could support all kinds of other types of science and experiments.
Yeah, it's wonderful to have such support that we've had to be able to do this so long term. It's a fantastic data set that I work in a management agency, but I try really hard to connect with researchers so we can really value add to the information that's there as well. But yeah, I do kind of regret the days miss the days of only having so much data to deal with. It's a bit different.
Thanks, Kieryn.